Dear Dynacom family, welcome back. Over the years, we have seen many developments in vessels' mooring systems to improve the safety of the people involved in the mooring and to improve the reliability of the mooring systems. Now, the requirements clearly define the main parameters of a mooring winch and a windlass. This also means that there are parameters of a mooring system that need careful evaluation for their correct deployment, and there are some specific maintenance requirements that need to be adhered to. In this respect, we have already made a video about the correct procedure of testing BHC. In today's video, our main focus would be the common observations noted on vessels' mooring systems that can and may lead to the objection on a vessel's mooring systems by third parties, ports and terminals. A common observation noted is the use of wrong size of brake linings on winches and windlasses. This includes both the thickness and the width of the lining. This is obviously incorrect. If the lining is undersized, that is, if it's narrow, its holding power is bound to deteriorate pretty quickly and its reliability over the time isn't guaranteed at all. An undersized lining is sunk in if you see it from the sides of the brake band. Like here, it's a new brake lining and we can easily see it from the sides. If the lining is undersized, it won't be observable from the sides. If the brake lining is oversized, that is wider, it will be protruding out from the sides of the brake band and can and will rub against the metal parts of the winch and windlass that it is not supposed to rub against, and hence it will deteriorate very quickly as well. Similarly, a thick brake lining will cause the band not to fit properly, resulting in a brake lining resisting the free movement of winch windlass even if the brake is completely open. And a thinner lining will cause the holding screws not to sink in the lining properly, resulting in screws rubbing against the brake band, causing a phenomenal decrease in the brake holding power. So kindly exercise care when ordering the brake linings and consult the plans before placing any of your orders. Next, we shall be talking about the rendering point markings on winches and windlasses. It has been observed that in many cases the rendering markings on winches and windlasses is either incorrectly marked or is not there in the first place. This means that the crew on board is unable to correctly tighten the brake, which in turn could either lead to an under-tightening brake, where the mooring wire slips, pays out before the render load is reached, or over-tightening, where there could be potential damage to the mooring winch or fittings as a result of the brake not rendering when the rendering load is reached. Not to mention, this is a situation that can be easily avoided by marking the rendering points correctly. So here is a recap of everything that you have to fill in the form F16.10. First column is date tested. That will be obviously the date on which you have to test the brake. Then the drum ID. The drum ID, as you guys can see, we have stenciled over here, WW13. This is the drum ID that has to be mentioned in the column number 2. Then is the third column, the brake force. This is the brake force that needs to be applied above which the brake has to render. This column, the brake force F and the render load in kilograms, both of them should be the same. Next is the drum dia. This we have to find out from the maker's manual. If not in the maker's manual, all you have to do is from the center of the drum to the flange of the drum. You have to measure it manually if it is not given in the maker's manual, but usually it is. Next is the wire dia. Wire dia you can find out from your wire certificate. The next is the jack area. Jack area, as I mentioned, that we have to either measure it manually, or if it is given in your winch manual, then you have to find it out from there.
I have already explained to you how to determine this exact value, but in general, you should keep in mind that the jack area is nothing more than the area where the inner piston is pressed up by the hydraulic oil. It is approximately this area that is shown in this video and not the entire jack area.
Next is L. L is the distance between the center of the winch and the point where you're going to apply the jack pressure. Next is the jack pressure. As I've mentioned earlier, jack pressure is the pressure which will exert the load equal to the render load above which your BHC will be able to render. And that we have to find out from page number 2 of your form F16.10. Tag distance is the last thing to be measured that we have to measure manually. Just for your reference, on our winches, the tag distance is going to be from this point up to the center of this pin. But obviously this we have to measure in the last. And the next is the render load, which is going to be the 60% of your ship's design MBL. Ship's design MBL will be mentioned in the last column. 60% of that will be mentioned in the render load. And the same will be mentioned under the brake force that needs to be applied. And one more thing to remind, that don't forget to change the units wherever they are desired in order to fill up this form correctly. The gears of a ship's winches and windlasses are built to last. And the gear oil is the thing that keeps them running smoothly without a hitch. It is imperative that not just the gear oil is kept to its optimum level, but the gear teeth of a windlass winch are kept properly lubricated. This will keep them running for life. Before usage, Check and see if the gear oil is milky in appearance. If it is, it shows that there is water ingress in the system. Change the oil timely. If you don't, this water can corrode the bottom of the gear oil tank and subsequent leakage of the oil that could potentially lead to the wastage of the gears and loss of lubricating oil. Take care of this and your winch or windlass gears will run trouble-free. As a general practice, do not forget to inspect the underside of winches or windlasses whenever the time permits. As we mentioned in our previous video that whenever the oil drips, the gravity will pull it down and the underside of the winches or windlasses will give you the first idea of any leakage, etc. This holds true for water as well. Whenever seawater or rainwater is sprayed on the windlasses or winches, the residual water drips down, which means the underside of a winch or windlass is more prone to catching rust than the top. The earlier you catch these defects, the quickly you can take remedial actions. The brakes of a winch or windlass are prone to getting stuck in their position if not operated regularly. The reason can be a prolonged voyages and especially the one where you got rough sea spraying all over the winches. Although they can easily be freed up by just giving a couple of rotations to each winch or windlass under power. But if such situation is faced at a port or terminal, it can lead to a bad first impression of the vessel that is not desirable. Hence, we strongly recommend that prior arrival any port or terminal, inspect the brakes and brake linings and move all the onboard winches and windlasses to free up any potentially stuck brakes or brake linings. If the bushes of a windlass or winch are not properly lubricated or greased, they are more prone to wear over time. Some may wear down with the age also. The indication of a worn out shaft bush is that wobbly movement of a winch or windlass when operated. The bushes are the ones that keep the winch or a windlass drum moving smoothly on the shaft. And they are there to protect the wear and tear of these drums in case they rub against each other. Simply speaking, these bushes save you from a larger defect where the drum barrels get worn out, resulting in complete incapacitation of a winch or windlass. They get wasted so that the drums won't. So it's imperative that they are kept properly greased and lubricated to avoid any such wastage. In case that the bushes are appearing wasted over time, change them timely or change them in the dry dock to avoid any unforeseen delays or issues. Another defect that has been observed is the hydraulic oil leakage from the operating levers, flanges and the gears of the hydraulic winch and windlasses. As we said before that whenever you are arriving in a port or terminal, try out all of your windlasses and winches. And we suggest even before that, you see if there is any hydraulic oil leakages from the operating levers, flanges or anywhere else in the windlass or a winch and try and rectify it before it causes any further troubles. Apart from the other factors, the cosmetic maintenance of a windlass or winch is also important. Because just like many other things, this gives the first impressions to the people who are visiting the ship. A cosmetically well-maintained winch or windlass also gives the impression that it should be working normally and fine in every other regard. So although all the maintenance on every winch and windlass on board a vessel is important, it is also important to maintain a winch or a windlass cosmetically. It has also been observed in some cases that the stenciling and marking on winches or windlasses is not correct. Either the arrows are pointing in the wrong direction, the safe working load is not correctly marked, or the winch IDs are not correctly marked. All of them are neither correct nor professional, and they can even lead to the crew who's operating the winch or windlass to move the winch or windlass in the wrong direction if the arrow is pointed incorrectly. So we suggest and recommend to check all of your onboard winches and windlasses and ensure that the correct marking is done. It has also been observed that these locking pins of winches and windlasses in some cases are absent. The absence of this pin means is that once you'll be engaging this lever, you'll obviously be not inserting this pin when the winch or windlass is in operation. What can happen is that the winch or windlass gear could jump out. This means that you'll be paying out uncontrollably, and in case you are heaving it, you may not be able to heave the wire at all. And this can lead to further damages and consequences that we want to avoid. So for the safety of everyone, please make sure that these pins are there on every winch and windlass. Although on board this ship we do not have the hydraulic brakes, but in case you do have the hydraulic brakes on your winch and especially the windlasses, please make sure that hydraulic hoses are in good condition. Their connections are in good conditions. There is always sufficient oil in your hydraulic brakes so that these brakes can be easily applied and easily removed. Because as a seasoned mariners, you can understand that if these things do not work, when they are supposed to. This can not only cause the undue inconvenience, but of course it can raise observations from third parties as well. Another important thing that comes into mind when we are talking about the forward and aft hydraulic winches and windlasses is this interconnection valve that connects the forward and aft hydraulic machinery. On many vessels, it has been seen that this valve is stuck in the position. We have recently operated it and it is working fine. I suggest that you guys also check this interconnection valve on your vessels. In case it is stuck, get it freed. This will help you in operating the aft machinery using the forward motors in case your aft hydraulic motors are not working correctly. And this will also help you in operating your forward machinery in case your forward hydraulic motors are not working well by just starting the aft hydraulic motors. On many hydraulic windlasses, there are two types of settings. One is the low speed and one is the high speed. If you put the windlass on the low speed, obviously it will heave up and it will lower the anchor chain quickly. If you set it on the low speed, it will heave up and lower the anchor chain slowly. Although we don't want to be impulsive, and please feel free to choose between the low speed and the high speed, but please choose it appropriately. For example, when you are lowering the anchor, always keep it on the low speed, because at low speed your windlass will give you the most power and your windlass will lower the anchor easily to the seabed. Similarly, when you are heaving up the anchor, if you are just picking up the slack, that is initially, you can use the high speed and you can heave up the anchor chain. But once a few shekels remain or as appropriate to the depth where you have dropped the anchor, in the last stages of heaving up the anchor, put it on low speed. You will get the most power out of your windlass and your anchor will come up nicely. Also, it has been observed the mooring system trips because of an increase in temperature of hydraulic oil. This is usually because the cooler of a hydraulic winch is either not properly cleaned or there are some tubes inside that are clogged. The VMA clearly states the duration at which you have to clean the coolers of hydraulic winches and windlasses. But if you are in any doubt whether your cooling system is working properly or not, do not hesitate to open and check it, especially if you are coming from an area where there was river water. Even a small straw that goes inside the tubes can clog this tube, and if a tube is clogged, the efficiency of the cooler is reduced. So make sure to clean it timely. These were some of the very common seen defects that can be very timely avoided, and we hope that this video helps our onboard staff to take care of their winches and windlasses and avoid any undue inconveniences. If this video was helpful, then ensure to check out our other videos where we have talked about hydraulic oil leakages and their remedy on board a ship. With a wish for smooth seas and tailwinds, it's goodbye for now.